Hello students, today we will start with the most important topic of an array. There will be a definite one question in the theory exam that how you can represent an array how you can represent two-dimensional array in memory. These questions are also asked in GATE and NET papers. There are two different techniques, one is row measure and another is column measure. In this video I will cover with रो मेजर ऑर्डर. रो मेजर ऑर्डर में एरे के जो एलिमेंट्स हैं दे आर स्टोर्ड रो वाइज. सो वी कैन से दैट रोज आर लिस्टेड ऑन द बेसिस ऑफ नंबर ऑफ कॉलम्स. सबसे पहले तो एलिमेंट्स आर स्टोर्ड रो वाइज and the rows are listed on the basis of columns. So for example, if I have an array like this, suppose एक array है मेरे पास ऐसे A00, A01, A02, then I have A10, A11, A12, A20, A21 and A22. So this array will be stored in memory using row measure like this. Suppose this is the sequential memory. So in this sequential memory the elements will be stored row wise. सबसे पहले ये वाली रो स्टोर होगी. इट विल बी लाइक A00, A01, A02, then this row will stored. So A10, A11, A12, then this row will get stored. So A20, A21 and A22. So this is row 1. This is row 2 and this is row 3. So in this way row measure order works. So the elements are stored on the basis of rows. Now the question that comes in the exam is to find an address of an element using row measure order. So उसका फॉर्मूला है वो आप नोट कर लीजिए फॉर्मूला. So the formula using row measure order is address of an element is equals to base address plus size of the element bracket n I minus L1 plus j minus L2. This is the formula that is used to find the address of an element using row measure order. Now we will see what each of this term is representing. So this B is the base address. W is the size of the element and n is the number of columns. Here n is number of columns. हम यहाँ पे किसका एड्रेस निकाल रहे हैं? सपोज Aij का. So I is the desired row which I have to find and j is the desired column of the element for which I have to find the address. L1 is the lower bound of row and L2 is the lower bound of column. So this is the formula from which you can find the address of an element using row measure order. Now let's see one numerical based on this formula. But before starting the numerical, I want to discuss one more thing. नॉर्मली जब क्वेश्चन होता है तो क्वेश्चन में एरेज को डिफाइन करते हैं समथिंग लाइक दिस, दैट एन एरे इज गिवन लाइक दिस. अब इसमें से आपको कुछ ज़रूरी इंफॉर्मेशन फाइंड आउट करनी है. सो द फर्स्ट डायमेंशन दैट इज गिवन इज द लोअर बाउंड. It is the lower bound of the row. This is upper bound of the row. This is lower bound of column or the second dimension of an 2D array, and this is upper bound of column, and the number of rows are given by upper bound minus lower bound plus 1. So upper bound of row is 15, lower bound is 10 plus 1. So the number of rows are 6 for this particular array. Similarly, number of columns is given by upper bound minus lower bound plus 1. In this, upper bound is 2, lower bound is minus 2 plus 1. So the number of columns are 5. You can also see that if I represent this, so the number of columns are minus 2, minus 1, 0, 1 and 2. 1, 2, 3, 4, 5. So 5 columns and 6 rows are there in this array. So this array is nothing but it is a representation of array 6, 5, where 6 are the number of rows and 5 are the number of columns. So now let's see one question based on this row measure order. Suppose the question is given as like this. There is an array is given like this. It requires 2 bytes for storage of each element. And I have to calculate the address of 6 to, given that base address is 100. So this is the question. Now let's see how we can do. If you remember the formula, address of Aij is so the address of Aij is equals to base plus W, number of columns I minus L1 plus J minus L2. So now let's see what is given to us. Base is given to us as 100. W is given as 2. So W is 2. And I have to find for this. So I is 6. And J is 2. Now what I need to find is N basically. So looking at this array, we can find the number of N. Now L1 is the lower bound for row and 4 represents lower bound of row. So L1 is equals to 4 and L2 is lower bound for column, which is minus 1 in this case. So L2 is minus 1 and the number of columns is equals to upper bound minus lower bound plus 1. So upper bound of column is 3. Lower bound is minus 1. So the number of columns is 5. Now let's put all the values in the equation. So we will get 100 plus 2 into 5, 6 minus 4 plus 2 minus 1, which is equals to 100 plus 2. 5 into 2 is, this is 2, so 5 into 2 is 10, plus 2 plus 1 is 3, so it is 100 plus 13 into 2 is 26. So the answer is 126. This is how you can perform the memory address calculation in a row major order. Thank you for watching the video. Please subscribe to the YouTube channel for more tutorials on data structure and other computer science related subjects. Thank you.